In this video, we are going to talk about the basic physics underlying medical optics. Let's look deeper into this. The important thing that we are going to look at is about photon migration through the tissue. That is, how does light travel through the tissue? We see that some wavelengths or some colors of light travel through the tissue differently than some others. There are simple ways to see this.
One of the properties that enable us to do this is related to how light is absorbed in tissues. Absorption means you're losing things. We are opaque normally, but the whole premise of this story relies on getting light deep into tissues. And this relies on something like this. This is white light. It means it contains many colors, many wavelengths of light. Now if I hold it towards you and I bring my hand to the back of it, you can see that my hand looks red. That means some light was able to go through more than a centimeter thick fingers of mine, but it looked red. It didn't look white anymore. I can do it in blue and nothing comes through. We can skip green, go back to red, and you see things go through here. This is quite interesting. It is not a big surprise. A little baby notices this often. This property, if I understood well, and we understand it very well, allows us to use several colors of light to decipher what has been absorbing them and to figure out the concentrations of them. In this case, oxygenated and deoxygenated species of hemoglobin.
We saw that different colors of light travel differently through the tissue. There are two aspects to it. First is absorption and second is scattering. Let's have a closer look again at what happened when we shined light through the hand. You could not see Turgut's bones. And that is because the light that was traveling had diffused. This means that light did not just travel in a straight path, but it somehow traveled in a zigzag path through the tissue. You also see this when there is sun behind the clouds, and you can still see some of the glow through the cloud. There are various kinds of light sources available to us, and in medical optics, it is important for us to make use of lasers. Let's see why.
So let's talk a little bit deeper about lasers. One of the cool properties of a laser is that you take a laser, you turn it on, and then you see this line and it points on things that are far away. That is because lasers are coherent. They contain only one single wavelength of light. Of course, how coherent of them depends a lot on physics, etc. But for our purpose, let's say they are coherent. This is cool. You can use lasers to do many things, and at ICFO we do many things with lasers using this property. But if I also wanted to use a laser to illuminate this room, that doesn't work well. If you've ever been to a laser show or you watched, first of all, it hits different particles and flickers, but if you look at also the point that it hits a surface, you see bright and dark spots. These are called laser speckles. These were a major annoyance for the people who first invented lasers, but once they understood them, they realized that they carry information. So just like flickering of lights on waves and figuring out how much those waves are moving, what we can do is look at these properties of lasers and this flickering of bright and dark spots and to measure something called blood flow.
In summary, we saw that absorption and scattering are properties of light that make it possible for us to study more about tissue. And all this is made uniquely possible with the use of lasers.